Hello everyone, I am Sneha Rendra Kamble. Today I am presenting of my ISC1 of Computer Architecture. My topic name is Interrupt Handling. Handling multiple devices. Actually, this is the challenge for the CPU. Is that the processor is doing something. Whenever the IO device wants to transmit the data, it will be interrupting the CPU by sending the interrupt signal request. The CPU, when it receives the interrupt signal request, will know that the IO device is now ready to transmit the data. So it will be jumping on the some ISR um, where the data transfer will take place, and after that the return back to the program which it was executing. Suppose that the number of devices are capable of generating the interrupts are connected to the CPU. The following questions are need to be answered. These are the challenges for the CPU. It finds it's handling the interrupt. How can CPU identifies the interrupt device? How can the CPU obtain the starting address of the appropriate ISR? How should interrupt nesting be allowed? How should two or more simultaneous interrupt requests be handled? Uh, Now what happens when the interrupt request arrives? Mm, At the end of the current instructions execution, the program counter and the program status word, which contains the status flag and the processor information, are automatically saved on the stack. And once the interrupt is acknowledged, the interrupt vector is retrieved, allowing control to transpose the corresponding ISR. Different interrupt devices may distinguish the ISRs tailored to the needs. After that, after handling the interrupt, the ISR uses the return from the interrupt and means RTI instruction to the restore and PSW and return to the saved PC that differs from a normal return which doesn't restores the PSW. In MIPS instruction cycle consists of the 5 machine cycles. Um these are the 5 instruction cycles. IF means instruction fetch, instruction decoder, execution, um, memory, and write back register. Um, in that, these are the 5 instruction cycles of the MIPS 32. After completing the cycle, the interrupt acknowledged at the place of the write back registers. In between of these instructions, the interrupt are not acknowledged. After that, the gentle interrupt processing. Um, these are the steps for the interrupt handling. Uh, the blue part is handled by the hardware and the pink part is handled by the software. The device controller issue an interrupt and CPU finishes the execution of the current instruction. CPU acknowledge to the interrupt and the CPU pushes the PSW and PC in the stacks. The CPU loads the new PC value based on the interrupt. In software part, it's saving and processing the interrupt request and restores the processor state information and restores the old PSW and PC. These are the steps of that diagram uh, which we are discussing. Um, Device controller sends the interrupt request to the CPU. CPU finishes the current instructions and sends back sends back interrupt acknowledgement as we are shown. Device controller sends the interrupt vector over the data bus and the CPU reads the vector and identifies the device. This is the diagram for the how the interrupt vector sends on the data bus in the response to the INTA. INTA means the interrupt acknowledge. The multiple device interrupting the CPU. A priority interrupt controller manages the multiple devices and interacts with the CPU. It assigns the priority to the simultaneous interrupt request and sends the correct interrupt vector to the CPU. After that, we moving towards the how it's work. The interrupt request lines becomes active when any device is rises in the interrupt request. It combines the signal from the multiple devices, INTR 0, INTR 1, INTR 2, INTR 3. When the CPU responds the interrupt controller acknowledges and the device and the sends the interrupt vector on the data bus. The interrupt controller is programmable, allowing the interrupt vector is to be set. If multiple interrupts are active, priority systems are used. Example, the interrupt request 0 has highest priority, followed by the interrupt request 1, etc. How is interrupt nesting handled? Consider the scenario. In this scenario, while the CPU is executing the ISR for the device D0, another device D1 interrupts. There are two possible outcomes. D1 can preempt the ISR for the D0, getting the process first before resuming the ISR for the D0. The ISR for the D0 can complete before D1 is handled, depending on the priority and the configuration. In this case, the D1 interrupt is ISR for the D0 and we processed first, resuming the ISR for the D0 afterwards. This scenario can complete multi-nesting of the interrupt. 2 hours the interrupt system can automatically disable whenever and the interrupt is acknowledged, preventing the need for the nesting the interrupt handling. The typical instruction set architectures have the following instructions. In this scenario, the ISR will issue and the enable interrupt instructions just before the RTI return from the interrupt, and some instruction sets architectures ISS combine EI and RTI into the single instructions for the efficiency. Now we move towards the cases that makes the interrupt handling difficult. Some certain interrupts completing the current instructions may not be possible. In such cases, a special return instruction is needed to be to the return the interrupted point and restart the execution of the instruction cycle. For examples, some example is there. The page fault interrupt, the triggered when the memory location is accessed that is not currently available in the main memory. And the second one is the arithmetic exception, the occurs when the error is arising during the arithmetic operations such as the division by the 0. This is all about the interrupt handling. Thank you.